guys! Welcome to BSECE 33 channel. Napag-usapan natin sa mga naunang lesson ang tungkol sa parts ng BJT, which is collector, emitter, and base. At sa lesson ito, we will talk about the common base configuration. The common base terminology is derived from the fact that the base is common to both the input and output sides of the configuration. In addition, the base is usually the terminal closest to or at ground potential. So throughout this text, all current directions ay tatawagan nating conventional flow or susundin natin yung conventional flow rather than the electron flow. The result is that the arrows in all electronic symbols have a direction defined by this convention. Recall that yung arrow in the diode symbol is defined the direction of conduction of conventional current. Another is the arrow in the graphic symbol defines the direction of emitter current or conventional flow through the device. So all the current directions na nag-a-appear sa picture na makikita natin sa slide is the actual directions as defined by the choice of conventional flow. Note natin that in each case, IE is equals to IC plus IB. So meaning, lahat ng current na nanggagaling sa emitter ay equal sa pinagsamang current ng collector and base. Note also that the applied biasing voltage sources are such as to establish current in the direction indicated for each branch. Another, that is compare the direction of IE to the polarity of VEE for each configuration and the direction of IC to the polarity of VCC. To fully describe the behavior of a three-terminal device such as the common base amplifiers of figure 3.6 requires two sets of characteristics. Una, yung driving point or input parameters, and yung pangalawa naman is yung output side. So yung input side for the common base amplifier as shown in figure 3.7 relates an input current IE to an input voltage VBE for various levels of output voltages VCB. So the output relates, yung output set naman, nire-relates niya yung output current IC to an output voltage VCB for various levels of input current IE as shown naman sa figure 3.8. So the output or collector set of characteristics has three basic regions of interest as indicated in figure 3.8, yung active, cutoff, and saturation regions. The active region is the region normally employed for linear undistorted amplifiers. We should always remember na sa active region, the base emitter junction is forward bias whereas the collector base junction is reverse bias. So the lower end of the active region, the emitter current IE is 0 and the collector current is simply that due to the reverse saturation current ICO as indicated in figure 3.9. The current ICO is so small na maano lang natin siya na microamperes in magnitude compared to the vertical scale of IC na milliamperes, that it appears on virtually the same horizontal line as IC is equals to 0. So note din natin that as the emitter current increases above 0, the collector current increases to a magnitude essentially equal to that of the emitter current as determined by the basic transistor current relations. Note also that the almost negligible effect of VCB on the collector current for the active region. As inferred by its name, yung cutoff region is defined as that region where the collector current is 0 ampere. So sa cutoff region, yung base emitter and collector base junctions of a transistor are both reverse biased. The saturation region is defined as that region of the characteristics to the left of VCB is equal to 0 volts. So yung horizontal scale dito sa region na ito was expanded to clearly show kung gaano ka-dramatic yung change in characteristics in this region. Note also na yung exponential increase in collector current as the voltage VCB increases towards 0 volts. Sa saturation region naman, makikita natin that the base emitter and collector base junctions are both forward biased. The input characteristics of figure 3.7 reveal that for fixed values of collector voltage VCB, as the base to emitter voltage increases, the emitter current increases in a manner that closely resembles the diode characteristics. So, in other words, yung effect ng variations due to VCB and the slope of the input characteristics ay may ignore as we strive to analyze transistor networks in a manner na nagpro-provide ng good approximation to the actual response without getting too involved with parameter variations of less importance. It is important to fully appreciate the statement made by the characteristics of figure 3.10c. They specify that with the transistor in the on or active state, the voltage from base to emitter will be 0.7 volts at any level of emitter current as controlled by the external network. In fact, yung first encounter of any transistor configuration sa DC mode, one can now immediately specify that the voltage from base to emitter is 0.7 volts. If the device is in the active region, a very important conclusion for the DC analysis to follow. So we have an example here, the example 3.1. So A, using the characteristics of figure 3.8, determine the resulting collector current if IE is equals to 3 mA and BCV is equals to 10 volts. B, using the characteristics of figure 3.8, determine the resulting collector current if IE remains at 3 mA but VCB is reduced to 2 volts. C, using the characteristics of figures 3.7 and 3.8, determine VVE if IC is equals to 4 mA and VCB is equals to 12 volts. D, repeat part C using the characteristics of figures 3.8 and 3.10. So for letter A, yung solution niya, it is clearly na sa characteristics sinasabi that IC is approximately equal to IE. Therefore, IC is equals to 3 mA. For letter B naman, the effects of changing VCV is negligible and IC continues to be 3 mA. So kahit ano man ang effect, kahit ano man ang gawin natin sa VCV, negligible pa rin siya kung kaya't yung IC pa rin natin is stay at 3 mA. For letter C naman, yung alam naman natin that from figure 3.8, IE ay approximately equal to IC. Therefore, IC is equals to 4 mA. On figure 3.7 naman, yung resulting level of VBE is about 0.74 volts. Again, sa letter D naman, IE is approximately equal to IC is equals to 4 mA. However, dun sa figure 3.10c na nakita natin sa previous slide, VBE is 0.7 volts for any level of emitter current. For this slide, we will talk about the alpha. So sa DC mode, levels of IC and IE due to the majority carriers are related by a quantity called alpha and defined by the following equation. So we will take note or lagi nating tatandaan that alpha DC is equals to IC and IE, kung saan yung IC and IE are the levels of current at the point of operation. Another is, since alpha is defined solely for the majority carriers, pwede rin natin sabihin that IC is equals to alpha IE plus ICBO, kung saan yung IE is equals to 0 mA, IC is therefore equal to ICBO. Another naman, for AC mode, for AC situations where the point of operation moves on the characteristics curve, an alpha is defined by alpha AC is equals to the delta IC over delta IE. So we will take note lagi itong mga formulas na to. So the AC alpha is formally called the common base short circuit amplification factor for reasons that will be more obvious sa mga susunod na chapters. The proper biasing of the common base configuration in the active region can be determined quickly using the approximation IC is equals to IE and assuming for the moment that IB is equals to 0 mA. The result is the configuration of figure 3.11 for the PNP transistor. The arrow of the symbol defines the direction of conventional flow for IE is equals to IC. The DC supplies are then inserted with a polarity that will support the resulting current direction. For the NPN transistor, the polarities will be reversed. So in the breakdown region, as the applied voltage VCV increases, there is a point where the curve takes dramatic upswing. This is due primarily to an avalanche effect similar to that described for the diode, when the reverse bias voltage reached the breakdown region. So as stated earlier, the base to collector junction ay reverse bias sa active region. But there is a point where too large a reverse bias voltage will lead to the avalanche effect. The result is a large increase in current for small increases in the base to collector voltage. Lagi nating tatandaan that in each of the above notation, the use of the uppercase letter O to represent that the emitter leg is in the open state or not connected. It is also important na tandaan natin when taking note of this data point that this limitation is only for the common base configuration. Ayun lamang po for this lesson. So thank you for listening and abangan nyo ang aming next na video which is about the common emitter configuration and common collector configuration. Thank you!